Welcome, guys. As today is our last session for this webinar series, I will just sum up what we have done so far, and so that this session can be helpful for whoever will be seeing these videos later on. So we had done a last few sessions on AWS serverless topics, mostly from introduction with AWS to introduction to serverless, and then a couple of hands-on labs with some serverless CI/CD introductions, along with architecture designing with some specific serverless services introductions also. With our last session with databases, this will be a combined session with a hands-on lab for mostly key serverless services like API Gateway, Lambda, and DynamoDB, along with one mostly used AWS tool called Amplify. So yeah, let's dig into it. This session we will be mostly focusing on having a hands-on experience with these key serverless services, combining them, all of them, in one application, and see how these services can work together hands in hand and give us some amazing results to build our serverless applications. The services we will be using today is Amazon Amplify, Amazon API Gateway for REST APIs, Amazon DynamoDB for our data storage, Lambda for serverless functions and all the computation logics, and AppSync we will be using to handle our database operations. So our database endpoint will be handled by AppSync as a GraphQL endpoint. So we will be using two types of APIs here: REST APIs for specific business case uses, and AppSync for database related operations. So yeah, and some tools which can be handy, like CloudFormation template to have the infrastructure ready for our application, Amplify CLI to build the entire infrastructure, and the CI/CD pipeline from Amplify to deploy our code, both from backend and front end. And for front end, we will be using React.js, and for backend, we will be using Python. Mostly Python will be used on Lambda to write Lambda logics, and React.js for front end. So this is pretty much it. The key services from AWS and the tools and the technologies we will be using for this hands-on. Mostly I will be demonstrating an application where we have used all of these services and tools to build a SaaS application. I hope this will help you imagine how serverless applications can help. This is the solution architecture. I have kept it as simple as possible to make you understand how all these services are used together to create the infrastructure. Obviously, the core infrastructure builder will be amplified to host all these backend services like GraphQL API for AppSync for GraphQL APIs, DynamoDB for data storage, API Gateway for REST APIs, and Lambda obviously for computation logics. And we will be using our famous authentication tool called Amazon Cognito for user authentication and authorizations for different rules and permissions. So yeah, this is it from our solutions architecture point of view. We could make it more complex by using some other sub services like S3, IAM, and other services which is used behind the scene, but these are the core and key features, key services which are used mainly. So yeah, this is it. But yeah, let's go for the next one where we will be demonstrating our practical implementation. So let's go into CLI and see which are the component used in this application. So if we go first of all in the main application there, we will be having the front end view of it, and main key feature of this application is to have some forms along with sign in features. So these are the forms, and these are the sign in. Okay, I may have been logged in, so if I just log out from there, yeah, so these are all default UIs used from Amplify, React UIs, to have these um, sign in and sign up features. So along with this, these are the forms which are handling data, insert and updates for our databases. um, yeah, so these are all the UIs. We could just log in there to see. Yeah, so these authentication is handled from Cognito, and this dashboard along with some other operations from it is being handled by GraphQL APIs along with REST APIs for specific business cases. Okay, so let's go into CLI and see which are the services used here in this application. So I'm on the application root folder, and if we type amplify status, we will be able to see all the services used there. So for authentication, we are using Cognito. These are the APIs from REST point of view. I mean the REST APIs, and these API for GraphQL, which is handling all the database storages. And along with these, there are some functions also. So these functions are connected with these REST APIs. So these three REST APIs are handling their backend operations inside these functions. So we will have uh, a overview of how these APIs are connected with these functions. But before that, let's see how these REST APIs are connected with these functions. So if you go as AWS console, there are yeah, so these are the APIs which are REST APIs which are handling different business logics for so if we go for hackathon management API, for that API I have kept a separate hackathon management function which is handling all the business logics. So okay, so this file is too long, I can show the code there, but this is not the main use case. Our main use case is to understand how this API is connected with our application. So you could create and have these APIs, REST APIs and functions from this CLI by running this command amplify add API for APIs and amplify add function for functions. So if you go along with these commands, you will have these functions and APIs created, but they are not, they will not be connected with each other. So for that you will have to update them to get connected. So for that you will have to run this command API amplify update API, where you will say that this API will get connected with this function. So these are pretty much self-explanatory commands. You could get all the overview from Amplify documentation itself. I'm just showing you how you could get these things done from Amplify CLI itself. So yes, Apart from this CLI thing, there is one more important thing is this thing for method execution response. Um, so here you could see this response header. If you want to have this 200 success message, you will have to configure these headers for each one of your REST APIs. These headers are can be handled from both places, either from CLI or from your function itself. If I go for the function, it is not there. Yeah, so this is the project folder, and on this amplify, inside this amplify folder, you will have this backend folder where you have all these components ready, your APIs, your authentication of component as Cognito, your functions, and your storage. This storage is S3, so I haven't talked about it, but we have used it. If you go for your APIs, you will see here it is your GraphQL API, and others are REST APIs. How you could identify them, that this is GraphQL, this is not by the name, but by the configuration of this folder. So for that GraphQL API, you will have this schema.graphql, but for other API folders, you will not have this, because these are not GraphQL APIs. These are REST APIs. So these REST APIs will have its own configuration setup on these CloudFormation template. Where this is auto generated by this CLI. If you run amplify add API and choose REST, then it will create these configurations on your behalf. This is auto generated, so you will get to know if this API is a GraphQL API or if it is a REST API. So by this folder structure content, folder structure and the folder content, you could see, you could get to know if this is a REST API or a GraphQL API. And if you go for functions, see, this is called independent serverless components. For each API, I have created a single standalone functions for hackathon management function, for participant registration function, so that these Lambda function is not spending a lot of time doing other operations. It is a standalone for that API call only, and it reduces your wheels. So yeah, also as I was talking about these headers could be done from two places, either from this console or from your code side. If I go any one of them, you could get this done from your return statement. Wherever you are returning it, you could set the header from there also, but I haven't set it here. It is not one of the best practices to set this header, because this could be immutable. You could change this, and if you change it, it will not work. This API will not give you 200 success code result. So it is always better to have this configuration on console side of it, so that it is not handled by anyone from your code side. So this is one thing to keep note. Apart from this, we have this GraphQL APIs, which is responsible for creating data storage. In our case, which is DynamoDB. So if you create this API, GraphQL API, you could see these types. These are all individual types holding separate, what is this called? Holding separate tables. So if you just create these GraphQL APIs only to manage your database operations, then it could be handy. I am following this technique to handle my database operations, but you could create done databases from CLI as well. So this is again another best practice from Amplify CLI, which can keep can be helpful to keep track of your database changes and other things. But I prefer to go with GraphQL, because GraphQL has that fastest operation runtime for database use cases. So yeah, I for all the database use cases operations I use GraphQL, and for all the business side logics execution I use REST APIs. This is this is my personal view to handle resources, serverless resources. You can be using your own preferences, but whenever you are creating these types from GraphQL, it will create individual tables on DynamoDB automatically. You don't need to manually do anything, and you don't need to even create DynamoDB tables from the CLI as well. These GraphQL schema will be responsible for that. So let's have a look. Let me just count it out how many tables I have. 1 2 3 4 5 6. So these 6 tables are types I have written here, and respective to these types you will have 6 tables on DynamoDB. 1 2 3 4 5 6. So these 6 tables are getting generated from that GraphQL schema. So it is one good point to update one place to get your database updated done, rather than doing everything manually from this console, create table and then use it from anywhere else, which is not a good practice. So yeah, this way we could keep track of database changes from the schema itself, which can be helpful in terms of access and permission management, and other types of authentications also. So again, these all can be learned from your Amplify documentation, how you could write a schema, how you could handle authentication and keys for your database tables. So yeah, this is it. I think apart from these functions, REST APIs, GraphQL APIs, we have one storage there, which I am not considering discussing, because this is only for specific use cases. You may not need it, but these things like GraphQL APIs, REST APIs, or these functions are mandatory things for any application, any serverless applications. So these are quite important to know about, along with authentication. So yeah, so these 4 and 5 options, components are pretty much standard for almost all the serverless applications. You will have to have these components for your application. Storage, S3 storage could be optional for your application, so that's why I've skipped it. I think yeah, this is it. If you want to know more about this, you can ask more questions about it. But yeah, this was it from my side, to describe you the services used and the tools used for this demo. Yeah, I think yeah, this is it. Let me know if you have any questions, or not only for this session, but for overall webinar sessions, because this is going to be our last session. So feel free to ask any questions or comments.